We're uploading this week's lunch gathering to YouTube. We hope that you'll enjoy it this way. If you would like to subscribe, there's a little red subscribe button down below and a little bell thing. And if you click on the bell thing, it will alert you to when new videos will be posted to the BDR Net channel. Let's see how it works. Thanks for listening. And let everyone know it's Clay Freinwald, longtime engineer in the Seattle area, EAS evangelist extraordinaire, and all around decent guy. The floor is yours, sir.
All righty. Are we seeing what I'm seeing?
We are.
Okay, I'm going to probably enlarge this a bit.
Good.
Okay, tell me when you got a decent sized picture you can resolve there.
Doing fine.
Okay. Well, what we're going to do is I've got a lot of pictures, and first of all, we're going to, please understand there's about 75 of these. So in order to get through them all, it's going to take a little time, and I'm going to have to buzz through them pretty darn quick. So first of all, I want to give you an orientation as to what we're looking at here. And this picture, for those of you who are not familiar with the Seattle area, this is Lake Washington, which is the big, long lake, about 20 miles long east of Seattle. This is Interstate 90, a couple of the parallel famous floating bridges going over to this land area here, which is called Mercer Island. You can just barely see the water on the other side of the island. And there are stair steps east of Seattle. The first step is this hill right here, which you can see covered with streets and houses. That's about 1,000-foot elevation. And by the way, for those of you in more southern climates, the snow level is going to be down to 1,000 feet on Sunday, which means the very top of this hill right here will be getting white. Then we go to the next hill beyond, which is this one up here. And we're going to go down to the next slide, and we can see this a little bit better. I just zoomed in on it. This is Cougar Mountain. And you can just barely, those of you who got enough resolution there can see right above where my cursor is, a tower sticking up there. There are several 300-foot towers on Cougar. That's where FM stations pretty much all migrated to when they, from various locations in the 70s when FM started becoming popular. And at one time, Cougar Mountain had 10 100-kilowatt FMs up there.
You can enlarge a little, Clay, excuse me, you can enlarge a little further if you'd like.
Okay. On Cougar is, let's see if we can get, that's, I can't get much bigger than that, I don't think. Anyway, on Cougar Mountain, there's a couple of things that were interesting with those 10 100-kilowatters, and anybody who's ever up there can verify this. All the light, they had fluorescent light fixtures in the buildings, and the light switches were high and low. You could never turn the lights out. And you could literally walk around with a 4-foot fluorescent tube in your hand as a flashlight at night. It was pretty impressive. Then some guy named Clay Freinwald said, you know, I think I'd like to move our station there. Well, at that time, we were in the middle of a big moratorium on any new towers and antennas. And this is where all the studies were done on NIER and death rays emanating from FM broadcast antennas. And so I said, well, okay. So what we ended up doing is building this tower right there. This is Tiger Mountain, actually West Tiger Mountain. East Tiger is right over here. This is West Tiger. And if you can just see above the cursor there, there's a 200-foot tower. And that was the one that I was the first guy to put an FM up there in 1987. We built that during the winter of 87, 88. And it's rather interesting. When I first turned it on, it was Clay's Folly. You're too far away. You're behind Cougar Mountain. It's going to be this wrong, that way. And as soon as we turned it on, the phone started ringing. And it turned out that Clay's Folly was a popular idea because there's now 13 FMs on West Tiger Mountain. Later on, American Tower came along and they leased some land from State Department of Natural Resources. We're on Weyerhaeuser land here. Over here at this site is these two towers that were built by ATC. The right-hand tower is, and you're going to see a lot of pictures of that, is predominantly television. And the left-hand tower is the FM broadcast antennas. So again, elevation-wise here, we've got Cougar Mountain at about 1,450 feet, and West Tiger Mountain at the summit up here is 2,948. And the towers are all the same height, so above sea level. So in other words, even though this is a higher site by 150 feet, these towers are 150 feet higher. So these are 350-foot towers. Anyway, there's an orientation. So let's scroll down here and look at this tower. This is the left tower at what we call West Tiger 2. And this was before the fire. What you see up on the top up here is just a pole. It used to be a television antenna for KUNS TV, part of Sinclair Broadcast now. They moved to their tower in downtown Seattle. And American Tower just wanted to leave the pole, understandably, because they wanted that light to be at the magic elevation. If they took it down in some lower elevation, somebody might, occupy your territory, claim your turf, and don't let go. Below that is the FM panel antenna. And this is a 4-sided tower, 8 high, 4 around. There are 32 bays. This was a plumber's nightmare beyond belief. And if you want to look up in an ERI catalog and see what this is what they call their cog or cogwheel antenna. And it sits on this transition, which we're going to talk about in a bit. And from here on down is a self-supporting tower of immense strength. The tower and the transition and the antenna, everything from here down was built by ERI. And this is a truss leg tower. To give you an idea how big this thing is, the face of the tower is about 2 foot across, and each leg is a 4-inch solid round. I understand a tower section weighs about 10,000 pounds, just a leg. So it's extraordinarily beefy construction. Down below here, you can see the one of the buildings at the site. This is a 2-story building. And there's 2 buildings on the site. One is generator and electrical power, and the FM transmitters and antenna, combiner, et cetera, are in this building here. So going down on top of Old Smoky, all covered with soot, this was a picture that was sent to me from a fellow who lives on a plateau north of the site. Hurriedly one morning, he called me on the phone. He says, "Clay, go look at your email. You've got to see this." And I looked at this and I went, "Holy smoke!" Well, maybe I didn't say that. Maybe something similar. And this is the antenna that is on fire. The wind is from the west, and it is a huge smoke trail blowing to the east, and it was really quite impressive. The fellow that called me, his name is Don Harvey. His dad is a broadcast engineer in Milwaukee, who's now retired, Nels Harvey. Anyway, moving on, another picture. This is an interesting one because it gives you a better idea of what was going on. Again, here's the TV tower with it's got a pickle fork candelabra on the top of it, or a T-bar, as some people call it. And here's the unused pole, and there's the smoking FM antenna. This was taken by the State Department of Transportation, and they got so many calls about a tower on fire at Tiger Mountain. They took one of their traffic cameras and aimed it up at the tower. Instead of looking at cars and traffic, now we're looking at flaming antenna. This was quite the conversation piece. So anyway, that morning, it was really interesting. Before I get far here, not only did I get phone calls early on, but I got a call from the fire department. And the fire department said, there's a tower fire. Yeah, I know that. Well, we've been getting calls from all over the place. Number one, how do we get there? It's about 6.5 miles of gravel road getting up to the site. Walt, I think you've been up there, so you can probably testify. And they said, well, okay. And I told them how to get there, where the gate combinations and all this stuff. And then they said, okay, well, once we get there, what do you think we could do? I mean, here's this fire department asking me, you know, how do I put out the fire, which is kind of novel. And I said, well, what you want to do is look for flaming stuff that's falling and make sure it's not setting something else on fire, because obviously we're in a forest up here. But it was quite a conversation piece at that time. Now we're going to look up at the antenna itself, and these are a series of pictures that I've taken. They're pretty much in sequence, but it'll give you a picture of what's going on. This is the top of the FM array. Here's a transition here going to that pole that was sitting above, and you can see this is these panels. And if you look over here at this one, I notice that fat one, radome, skinny one, no radome. This is where the fire began. Okay, we got a lot more. Now we're going to look up at the good antenna. This is what they're supposed to look like. And these things, if those of you who are into panel antennas, you understand a little bit more about it. For those of you who don't, well, I'll help you out a bit here. They're fed with 2 transmission lines from a power divider inside the tower. Inside this element stem here is a balun. These are series fed dipoles, cross dipoles. This device right here, this round thing with a bolt-on cover, is an insulator. And so what you have is a balun, 2 baluns feeding cross dipoles. And then they're tied, the radomes are tied to the back screen here, and a lot of tight pictures of those you'll see coming up. So let me speed up the process a little bit here. Just more pictures of what it looked like the non-damaged kind. And this gives you some ideas of these radome attachments. These things are interesting because these have failed in the past. And this is not the first time they had a problem with this antenna. There's one other occasion I know about that they found one of these element arms laying on the ground. Now, interestingly enough, you think, what did that do to the visual of the antenna? Not a lot. Remember, you got 32 bays up there. They're being fed separately, upper and lower half of the antenna, but you didn't really see a big change in match. And here we go. Here is a burned one. And you can see what's happened here is the radome is completely burned away. The thing that's interesting to note is I believe this is where the fire began, is right here. And if you'll notice also that this bracket is no longer holding this element in position. This thing is supposed to be up here a ways, but instead it's kind of drooped down. The only thing that's holding this thing on is a single brass bolt that runs through this insulator. They're all built the same way. And it's about a, I don't know, 3/8 inch, half-inch brass bolt that goes through there. And what it does is it bolts onto the radiator, and it goes across and bolts underneath here on this insulator, to which is a strap, piece of brass strap, probably 3/4 of an inch wide, that provides the feed from the balun to the radiating arm. But what happened is this is where the failure occurred, and Tom Sullivan has a report of which I am 90% in agreement with, that you can read, and it was published by Randy Stein, and it was on Radio World in November 21 of 2018, cause of Tiger Mountain fire disclosed. So if you want to read that, you can get some ideas. But this is where the fire came out. And when the fire came out, what it did is it ignited the radome. Now, the radome is made out of ABS. and its flash point is 507 degrees. And well, it caught on fire. And what happened there was interesting because, as you noticed, the wind was blowing. Well, the wind blew the fire around the tower, and these pieces of ABS, when they burn, they don't totally consume. They melt and burn and then drop down these fiery globs onto the antenna below it. So the wind pushed it around the tower, gravity pushed it down the tower. And this is what you ended up with, is a number of bays on all faces that are crispy critters. And this is an example of a piece of the garbage that dropped off of the tower. I just think, Barry, we can zoom this stuff here and see this. There you go. How you like that? That better, Barry?
Oh, yes.
Okay. This is, it looked like Batman's cape here. This is a guy wire on a radome, and this dripping goo that had melted off of an antenna somewhere above came down and caught on this wire, and it was all over the place. It was all over the ground. And it's interesting to note that the State Department of Natural Resources made American Tower come up and clean up the whole area. I mean, it was just globs of, tarry stuff all over. So the decision was, here's another glob laying there, you can see on the tower. The decision was made to take the antenna down and decide later. So you can see here's one that was, two of the radomes were burned off, two of them were not. And over here, again, a good idea of how incredibly beefy, I don't know if that's a technical term, that those towers are. And here's the two 6-inch transmission lines feeding the power dividers up in the antenna. So it's disassembly time. And here's a picture of the disassembly process. Here you can see people standing on the tower there with tool bags, and they're stripping off the bays off the face of the tower. This gives you another idea of how the burn bay here and no burning here, because the flame didn't go up much. It did here. I guess this is the place where it started, and the bay above it survived, and then it kind of blew it around and down, and all of these, as you can see, had flaming debris coming down, and it burned off all the radomes all the way down to the bottom. They were not sure, electrically what the antenna was going to be like, but the decision was made, let's take it all down and get something temporary up there that the broadcasters can use, because there's 5 FM stations here, and all 5 were at their auxiliary sites. And for those of you who look at it as an auxiliary antenna or auxiliary antenna on the same tower, or an auxiliary transmitter using the same tower, same antenna, this would have done you no good. Literally every station that was on this site has an auxiliary, but at Cougar Mountain. So everybody that was here switched to Cougar, albeit some of them were a whole lot less power, and they didn't have HD radio capability, etc. That's changing, by the way, quite a lot. Hubbard was one of the ones that jumped all over that and put on higher powered HD transmitters on Cougar for an auxiliary. Here you can see guys up there working away, unbolting that thing. What they have to do is unbolt that 4-bolt flange, releasing the bay and all the connections that are made to the back screen for the end of the radomes. And now on the ground, what we got is a pile of antennas, and that's kind of interesting. Again, you can see that 4-bolt flange here, and see the 2 white things there. That's the insulator for the connections to the input of the balance. But again, you have a mixture here. There's a crispy one and a partially crispy one. And there was a lot of antennas. There's 32 bays piled up. There was quite a pile of debris up there. And they just finally hauled it all away and said, that's it, we're done. This gives you some ideas of, again, what they look like. This is the flange that bolts the thing to the screen. This is the insulator. This is an intact antenna. But the thing that the mechanical stability of this thing required is just 2 points of mounting. There's that through bolt, that brass bolt here that sucks this up against the insulator. And then there's a little bracket that attaches, you can see the open hole here, attached it to the screen in the back. And if any one of those two fail, well, the bay fails. The boneyard. This is the generator electrical building. And by the way, there's north of 1 megawatt of auxiliary power in that building. Over here, they're assembling a little temporary antenna for one of the stations. One of the iHeartMedia stations said, we got it, our auxiliary, isn't good. We want to get back on it, Tiger, at all cost. And so what they did is they scrounged an antenna, and I think it's a Bext or something like that. It's I want to call it an off-brand, not a major antenna manufacturer, certainly, but and it's very lightweight construction, and they were getting it ready to go up on the tower. Another picture of the boneyard. And this is Joe Taylor, who is the site manager for American Tower. And these are a couple of guys that are working with ERI, not ERI, but CCOM erectors. And by the way, this was CCOM erectors' last job. Those of you who have known CCOM erectors, they've been a tower company in this area for many years, and this was their final project. At the end of this, they decided to close the doors. But anyway, there's this little antenna. There's a little story about this antenna, too. This was the first of 2 antennas like this. The first one they went to put up, they dropped. Well, obviously, that didn't survive. And they were able to get another one the next day and assembled it and got it up on the tower for KZOK 1025, one of iHeart stations. Here you see a part of the screen that they took down off the tower. So now here's the pole that used to have a UHF antenna on it, and the transition to the pole, the square tower with the back screen minus all the antenna bays. Yeah. Okay, I must have a blank one there. This is now looking at what they did with that temporary antenna. And we're going to zoom back a little bit here to let you appreciate that a little better. This is, you can see that, again, the transition on the square tower. This is where the TV antenna used to be, and they quickly put that little 4-bay up there and ran some 3-inch heliacs up to it, and that got it on the air for 1025. This is just another view of what it looks like. Again, the little temporary FM antenna. The other 4 FMs that were up there had to operate from their Cougar Mountain sites. They were able to operate up there until they started rebuilding this, which you'll see here in a bit. But it got them through a winter. Believe it or not, it did survive. In the meantime, ERI came up with this antenna here. I don't have pictures of it going up. Again, I wasn't there every day, but they put up this on the tower, which is a 4-bay Axiom. If you want to look into the antennas and look at the Axiom antenna, it's a half wavelength spaced antenna with a unique feed system on it. It's like a 2-bay and a 2-bay and a branch feed for that. And they're fairly broadband. And they put that up temporarily. So the guy that had the 1025 little lightweight antenna up here could be taken down. And now you see CCOM's big gin pole on there, and they're taking the pole off the top of the tower. So this is disassembly beginning here. And some more pictures of what a little wider shot here. And you can see them with a gin pole holding that former TV antenna pole. And there's the square tower that used to hold the master antenna. And some shots of what that looked like. Oh, by the way, I should go back up here. The wiring to the beacon did not survive. So the tower was dark. Okay, going down here, let's get into this. This is just a little tighter shot of what this transition thing is. This is important to understand because all of the steel is going to come down. They literally started from the self-supporting tower up. This is the big transition here between the tower and the square tower that held the FM antenna. You can see some of these screens in here that were part of decoupling between the bays of the panel array. That's the climbing ladder sticking out there. There's some pictures of that transition. This transition, they built a whole brand new one. And to give you an idea, this little piece of steel here is 16,000 pounds. It's just, 8 tons of steel just for the transition. Pretty amazing in terms of size. And there they're lifting it off. This gin pole is, I don't know, 150 feet long at least. It's giant. And this was child's play for CCOM. They just went up there and took it apart. Bang, bang, bang. There's the transition coming off. And so what we're left with here in this picture is just the top of that tower left with the gin pole sticking out. Over here is the TV antennas. One of them is now Scripps, was formerly Ion Media. Another one is Daystar. Anyway, there's the top of that tower. That's all that's left at that point. This is a good idea of what that square tower was built like. I mean, you talk about beefy. My gosh. It is using angle legs. Of course, how else you can do that? I guess you could do it with welded sections, but huge flanges. And these are brackets to hold transmission line pieces inside this. John Breckenridge, who owned CCOM Erectors, told me, he says this was his story. He liked to tell this one. He says, I'd have to strip naked. You'd have to grease me up so I could slither up through this thing. It was a terrible thing for anybody to go up and to service, change the light on the top of the tower. Lots of stuff on the inside. That's me holding how thick the plate is on the bottom of that square section, just to give you an idea. This is looking at the bottom of the TV tower here. This gives you an idea of what was inside that thing. Power dividers and all kinds of hardware in there. It's just an incredible, like I call it a plumber's nightmare. This divider right here with the 1 5/8" outputs went to feed a bay, and the bay was bolted on here. And there's one of the hybrids on the back of the bay. So there's an 1 5/8" feed going into this hybrid. This hybrid's got 2 gazatas, which feed the balun, which in turn feeds the radiating element. Kind of a tight shot of that same thing. These are rather standard ERI 3-port hybrids, and a power divider, and a big power divider. So you got power dividers, feeding hybrids, feeding bays. And this is, again, looking at that 3-port hybrid, has an 1 5/8" input, and it has these 2 1 5/8" outputs. And this is the 4 holes that the element stem is bolted onto. So it just plugs right on there, bolts on, and away you go. It's just do that 32 times, and you got an antenna system. This is the TV pole that was taken down. And to give you an idea how big that thing is, I mean, those are, large diameter bolts and lots of them. This stuff was all cut up and hauled away. I imagine CCOM probably made a lot of money on scrap. This is the transition that was on the top of the square tower, of which that TV antenna was bolted. And that was surplused, no longer necessary. Now we're starting to assemble the new tower that will sit on the top. And this is a triangular shaped tower, as you can see. And while we're at it, LED beacon going on. This is part of the winch assemblies. If you notice, there's 3 drums working here and 3 different cables. So they're able to very efficiently move things around up on the tower. And this tower, it's hard to tell, but this is the top. If you look at the leg is fairly skinny at the top. The leg increases in diameter as you go down. And let me move this thing up if I can. Hello. There we go. I don't know if you can see how that leg gets fatter, and even fatter down here. So anyway, it's a cantilevered triangular shaped tower sitting on top. And here's some more pictures of that. You can get an idea here how big the leg is. And these are higher sections, much smaller, all built by ERI. And lots of bracing on it. Everything is solid leg. They don't build things using pipes. They use this as an anchor for the winch assembly for a while because it's very heavy. This is going to bolt onto the triangular shaped tower transition. There's the transition, brand new, freshly minted. And in this picture here, it's upside down. But this will bolt on to the top of the triangular shaped tower, self-supporting tower. And this plate right here is where the tower sections you were just looking at will be bolted. Lots of gusseting. And again, they told me this was 16,000 pounds. And I can believe it. It's pretty beefy. Over here, antenna bays, cardboard boxes. And I guess the finger means up. So they picked it up with a boom truck and grabbed it with a line on the gin pole, and up the tower she went. By the way, this is an interesting comment here. This is the not the roof of the buildings up there. It's a gable roof made out of grating. And so what you have is a building with a flat roof with AC units and stuff on the roof, but the grating provides eye shield, and it works quite effectively. There's a lot of damage up there from falling ice, but the roof has been, the buildings, those ice shields on the roof have been up to the challenge. Here goes this transition work. Little people up there on the tower. And it was interesting when they got to this point, you could sure hear a lot of hammers banging up there. They were going to make this thing fit. And it took them a while, but they got it. There's that big square gin pole. So anyway, now we're ready to put new stuff up there. And this is what they put on the top. So what you have is this, we're going to zoom in on this a bit here. And I should have done the zooming earlier, Barry, I'm sorry. Again, the self-supporting tower, the new transition there, and then this new triangular shaped tower. And here you can see how the legs are fatter at the bottom and more skinny at the top. And at the very top, of course, you got to have a tree. Thankfully, there's lots of trees available up there. This gives you an idea of what it looks like. Now, at this point, that temporary antenna that was on the square tower, the ERI put up, that's now down laying on the ground. It will get shipped off to somewhere else. And everybody's back operating from Cougar Mountain. And this, by the way, is the following summer. So, you know, we went a year with until they finally got to this point. You can't build in the winter up there. That's it's just not feasible. This is an idea of one of the bolts I'm holding that holds these things together. You know, we're talking some large size hardware here. I don't know what that bolt weighs, but probably 20 pounds. Top of the tower. And they put these little guys up there on the top. I don't know how much good they're going to do, but we'll see. This is not lightning country, but when we do have thunderstorms, which is, not like other parts of the world. If you look at a map of frequency of lightning strikes, Seattle's on the low end of the curve, but they'll turn these outward so they're sticking out. And of course, the tree that the iron workers have to put up, and that was an American flag. But weather conditions up here, you're looking at 3,148 feet above sea level, and hurricane force winds are common. So it can get pretty gnarly up there. And now a comparison shot here of this now freshly installed tower, and there's the T-bar on the other side. I'd like to say about that T-bar is hard to put it in perspective, but it is big enough and strong enough you could put a Greyhound bus on it. It's rather large. Everything there is just tremendously rugged construction. Here's a picture. You can see the transition on the ground. These are not in exact sequence. There's the new tower section that'll go up, and all the boxes of antenna bays, pile of bolts. New antenna bays taken out of the box. And if you'll notice, these guys bolt on in a similar way, in that there's a 4-bolt square flange. They do some other tricks on this thing. This is a standard rototiller antenna that probably everybody's got one of somewhere. It's just that there are 16 of these. So instead of a 32-bay antenna wrapped around the tower, we're going to have a 16-bay antenna in line. Now, what they did here are the standard brackets. And by the way, I got to tell you about one of these brackets. One of these brackets, I can look right out the window and see at my house. It's holding my mailbox. Wonderful mailbox holder. Sitting on a piece of Roan 55G, by the way. But here they've got stiff arms. I don't know how many of you have got an FM antenna mounted on a triangular face tower with a stiff arm on it. Probably not too many. But this kind of speaks loudly to the weather conditions up here. And it's broken down into 4-bay pieces. And they will erect these 4-bay pieces 4 at a time. You can see how the feed works here. There's an elbow here into this T, goes into an elbow, and then goes into this guy here, and it's got the bays up and bays down. I'm not going to deal with the theory behind this, other than to tell you that it is a halfway spaced antenna. And when you move the antennas closer to each other, the mutual coupling between the bays will also broaden the bandwidth. And Walt, you can get into detail on that, but that's all I'm going to deal with today because there's a lack of time. Here you go. This is the antenna assembled, ready to go. This is again, the generator building, and over here is a 10,000-gallon diesel tank. It's to feed those big generators. They were thirsty. It was interesting when they started putting in parts and pieces up there. I went up there on a couple of occasions, and you could not see the top of the tower. We have the world's biggest cloud factory immediately west of us here. And as you know, a lot of cloudy days in this climate. And the clouds would just totally obscure the tower. And they're on walkie-talkies talking to somebody that they can't even see, hoisting loads up the tower. And CCOM was, these guys would work in no matter what kind of conditions. It never bothered them. Now you can see tool buckets here. The transmission lines are capped off at this point, and they are holding pressure. And we have to, of course, obviously build this out from there up. This is one of those foggy days. You can see the antennas are being assembled on the tower. Here's another 4-bay section going up, a piece of transmission line. Uh-huh, sure. Four bays at a time. When they got it all done, it looks like that. And they have a bucket they put below this thing, well, a big bucket, a container that they would use to haul parts and pieces and hardware up there. But this is, it looks like an enormous amount of antenna. It is. It's 16 bays. And it occupies all but the top portion of that tower. American Tower is holding on to that for who knows what may come, because obviously they're in the tower business. You get an idea of some of the ice shields up there, because these things ice up terribly. I mean, immense amounts of ice. And when they start shedding ice, wow, it gets very noisy. There's that container that they had for hauling parts and pieces up the tower. Here's a little closer look at the antenna. Now we have we're going to have to connect that 6-inch line here and here. There's an interesting part of this antenna. The old antenna was an upper and lower half as well, but it was a 50-50 power split using a big hybrid splitter. And the hybrid was probably 30 inches in diameter, great big tank. This is not a 50-50 power split. And I asked the guys on site, I said, what is it? He said, it's about a 2-to-1. So there's like twice as much power in this half of the antenna there is in this half of the antenna. How does that work, I asked. He said, you'll have to talk to Tom. So Barry, there's a good program. Tom Silliman, tell us how this thing works with unequal power into the upper and lower half of the antenna. I would like to know.
Good idea.
And I've got several different views of this. This is taken over from the west side. And I should tell you, too, by the way, that the ERI did put the stuff on their range. And yes, there was pattern distortion. As you well know, anytime you side mount an FM antenna on a tower, you got a directional. The question is, how directional? And it's going to vary as to frequency. And so they submitted that to iHeart, Entercom, and Hubbard. That's the three owners that are involved here. And they all said, and again, all the patterns are different. I mean, a little bit different. The highest frequency up here is 1061. The lowest is 92.5. So there was a lot of differences. And essentially, the wheels and decision makers in those companies said, okay, we'll go with it. I find it fascinating that the thing works extraordinarily well. And I've talked to the engineers, local engineers here, and I said, do you have any complaints? No. Now, part of that was they were just so thankful to get back to their main site. That kind of muted the complaints, I suppose. But even though there are nulls in various directions, none of them are real serious to the point that it's not within the AGC range of the average radio, I guess. This is a transmission line party day. Now we can see the pressure caps that are on there. There's a tower light that didn't quite make it, a piece of whatever. But this is all going to get replumbed together, and that's what the buckets are all about. It's plumbing time. So we got to this point here that the guys are, plumbing this all together. You can still see there's some missing gaps here. All the horizontal portions of the transmission line have ice shields over them, by the way. And there was a whole mess of these guys. Oh my gosh, they just had piles of this stuff. I knew CCOM was resourceful and they had a lot of equipment, but it was amazing. They didn't have to wait and go get anything. The only thing they had to wait for was interesting is when they got the antenna up there and they said, okay, here's where the antenna input is, and here's where the transmission line leaves, where it stops, where they were capped off. And I was on a conference call, and it was really kind of interesting. They said, well, do you have drawings of that? And there was nobody said anything. And the guys at CCOM said, look, guys, we don't know how long these things are to be made. And there was some suggestions. They go up there and measure it, and ERI would send out what the measurements showed. And there was a lot of back and forth just to get this thing connected. Mounting the antenna on there, no big deal. But getting all the plumbing put together, that was a big deal. And it took probably 2 or 3 weeks of delay just getting all that sorted out and all the parts. On the other tower, while this was, and this is a final picture we had up here. Let me zoom back up here. This is pretty much as it looks today. But on the other tower, on the left side, another antenna went up. And that's this one. And this was all done by another tower company, Harrington Tower of Seattle. And that's a Catrine that's on one of the television, low-power TV stations there on the other tower to the west. And that antenna is right there, that little Catrine, little two-bay. And there's the big FM antenna, and it's all plumbed together, and it's all cooking, and it's been operating failure-free. Now then, what does it look like in the wintertime up there? Oh, about like that. That was taken earlier this year. Now, here is the transmission line coming down here, 6-inch line, and then hitting horizontal and then down. And there's the ice shield to protect that horizontal piece from being bashed by ice falling from the tower. And there's an ice shield above the top bay, protecting it from ice falling from above. It gets pretty fierce up there. So anyway, that's kind of where we are, and with an iced up antenna. And so let me toss this up to anybody who has any questions that you may have.
Well, Clay, I've got a few questions.
All right, shoot.
You can hear me. First of all, I calculated that you have on the old antenna that burned up, there were 128 elements, basically element arms, because each bay had 4. It's 128. So if you divide the total input power at the bottom of the antenna by 128, that gives you the amount of power supposedly at the point where it burned. And then the question is, was that really sufficient power to create all that heat and burning? Which fundamentally you begin to wonder, or was it possibly some sort of arcing inside?
It was arcing inside. Yeah.
Right. So I have on my screen, if you want to switch the image to my camera, because it's not on this particular.
Barry, I can close this if you want to do that.
And if everybody basically looks at, go
ahead,
speaker view. So put speaker view in for me, and I'm going to turn this around because it's on the other computer. You're going to see the inside of the end of one of those bays, and it will show you the wiring and how each of those 4 element arms gets fed. I
apologize. I could have taken pictures of that, but you got it right there. I should have done that.
Right. So what you see there, these are Teflon coated straps, and all 4 of these are the 4 outputs of the balun. Let me show you a few more pictures that I can get here. My antenna, which is lower power, ended up being damaged by ice. And this element literally was ripped partly off its base. This is the root of an element, and you can see it sticking out from the radome, and it was sheared mostly off. Now there's a big flat brass or copper plate there that's basically welded to the tube of the element, and the center of that is bolted through the insulator, which is the white part.
That's that big brass bolt.
Yeah. Now there's a little bit of a hole here because it does go through, and there is sealing material. So obviously the sealant between the insulator and the and the bottom root is what started to leak. See, these are your air bubbles. The odd part about this is when this damage happened, I had no idea that we had damage, except that my Viswar improved significantly. I actually got a better match with one damaged element, but the dehydrator became rather unhappy over time. So somebody climbing up was able to spot that damage. Let me get a couple more shots here. So there's a rigger working on changing out a piece of transmission line, not transmission line, a piece of guy wire, and putting an insulated section on there. You can see the little guy up there. When that antenna went up, it's another. I've got better views of this antenna elsewhere. Oh, this went up in the middle of the winter, and my tower riggers come over to me and say, "Listen to this." Turned a bay upside down, and it sounded like a South American rain stick. So it's supposed to make noise like that? I said, no. Virtually on several of the bays, a lot of the hardware inside was not properly tightened down. And so we had all this loose hardware. And at any rate, it made ERI rather unhappy. They stopped production on their floor, and they sent a field service engineer out, pitched a tent, and took every one of our bays apart to to fix all the loose hardware. So that was a bit of a nightmare. This is an insulated arm that holds the end of the radome, fixes it so it doesn't flap around in the wind, and the back end would be eventually attached to a support on the rear screen, and that is what a bay looks like. These are the actual arms themselves are narrower than the arm that you had, because this is not a super high power antenna. But here again, here's a hybrid, and the 4 supports, which is why that bay got damaged, because obviously if ice fell down on it, it's not a heck of a lot, it's sticking out in the free space. It's a real issue. We replaced that antenna with a Shively that has a radome that covers the entire bay. So it's a lot more secure, and also you don't have elements hanging out the way that one was. But anyway, that's pretty much what the ERI looks like. This was a 3 around 2 height, total of 6 radiating sections for this particular antenna. I'll see if I can find you. You can see basically 2 levels and 3 around if you look over there. But pretty much similar design, but on a 3-sided antenna, you only have a back plane. You don't have separators out on that, because less necessary to avoid the cogging interference you would get when you have the various bays horizontally around feeding each other. And you can see the very, very top is UHF television antenna on this thing. This is a 450-foot tower, by the way, and that's about the 370-foot mark on it. And again, the guys plus the loads going up the tower for the ERI antenna. And at some point, I don't have it here, but I could look for it and show you pictures of getting the Shively in place and what it looked like. Definitely a different antenna for sure, and hopefully it'll be a little more secure. And I must say that even with Shively, we had issues. They sent the wrong mounting hardware, and so did ERI, by the way. Those insulated rods to hold the ends of the elements were the wrong size when the ERI antenna arrived. Somebody picked the wrong parts, and Shively did the same thing for different hardware. The only difference is that we had to wait for the ERI correct parts to get shipped cross country. The Shively parts were driven down in a car from Bridgeton, Maine, because it's only several hours away from where this tower was. So that was kind of convenient. But every antenna system or any project could be full of surprises. You really have to be prepared for whatever might transpire. You just never know. I'm probably a lot more happier with the antenna we have now, I never particularly cared for those elements sticking out like that far. To me, it looked like something looking, for hazard above you. I would think that with your Tiger Mountain tower, as long as there is no new UHF antenna put above you, you probably wouldn't have too much of an ice problem. I've had issues where you had a UHF television pylon and somebody forgot to turn the de-icers on. And when they finally do turn them on, these huge blocks of ice start coming down. And anybody below, if you don't have a good ice shield, ice guard, you're in deep doo-doo. So anyway, I just thought I'd add that, since it's basically the similar design antenna that you were showing, Clay.
Yeah, Barry, let me add a couple other little wrinkles here on the original Tiger Mountain Tower. That has a ERI panel, but that's a cavity-backed antenna. The radiating elements stick straight out. They don't curve back, but they use the same feed system, same balun, same insulating material, and they attach the end of the element radome to the edge of the basket. And we've had one of those break in the past. They came up with to ERI's credit, a much better attachment mechanism to attach the end of the radome to the basket. But in that case, we had one that started wiggling, and that insulating material won't handle that. It'll that antenna, by the way, is now over 30 years old, and we had it rebuilt this last summer. And all they did was to replace that insulating material and put all new, O-rings, gasketing, and whatnot. And it stopped the massive pressure leak because it was turning into a sieve. But that's the story of that one. That antenna, again, 30 years old at the site that was put up in 1988. So it's actually over 33 years old. Been good antennas. I've looked. We have a Shively panel antenna down at the Cougar Mountain site that American Tower has, which has got a big combiner. There's 10, 11 stations in that thing. And I will tell you that Shively antenna would not survive at Tiger Mountain. It simply would not. It's just not built sturdy enough. If I had to choose, I think ERI builds the more rugged antenna, and I think Shively builds the superior filters. Gordon's nodding there. If we could do it. I take people up to the Cougar Mountain and show them that combiner up there, and it's really a oh wow, because it's a huge long thing. And ERI's got some issues with how they do matching between the combiner modules by their application of slug to cure all things, which destroys everything else but makes this good. Shively does not have that problem. We can add stations as we have to that combiner, and they don't have to be in order of frequency. And you put it together, they put a network analyzer on it. There's nothing to be done but say it's good and walk away, and it just runs.
Right,
ERI has not had that success with the combiners. They work. I'll give you credit. They do work. They're built. They're rugged, but it's a different philosophy.
Okay, Clay, we have a couple of questions that have been stacking up here in chat.
Yeah, go ahead.
Let's start here with Tom wants to know, what did you use to take the photos?
I have, well, funny you ask. Right there. This is a Lumix. It is an FZ something another. You would ask me that. It's got a tremendous zoom on it. It's a 20 to 1200 lens on it.
It is good lens.
It's a Panasonic Lumix camera. Let's see. This is a FZ80.
Okay. David,
one thing I like about it is it's got a real viewfinder, or you can get the picture in the back if you want. And you can, and it's got image stabilization. So I'm able to really look at tight shots at things great distances away.
Very good.
If you guys want to take a quick look, this is the Shively antenna with the guys working on it, and you can see what the radomes look like. I ordered with the massive radomes intentionally to make sure it would be structurally as good as the old ERI had been, because of the possibilities with it. And this was taken with a Nikon Z7 using, of all things, a Canon 100 to 400 millimeter zoom lens. An amazing combination. You really can't see it quite as well with this.
You're going to have a lot of wind loading there, Ira, that some people couldn't handle.
Yeah.
Right. It's secure enough. You know, the wind loading was not that much different than the 4 individual radomes, one on each element.
Okay, Clay, David wants to know, was the non-panel design used to avoid another fire? He says, with population almost in one direction, the panel may not have been essential in the first place.
Well, okay. You brought up an interesting load of responses. The original antenna on the original Tiger Mountain Tower, the one that in that picture you saw earlier, the one on the west side, is a 4 high, 2 around, 2 sides. So it is an on-purpose cardioid. And the reason that we did that, and that was done in conjunction with all the original Tiger Mountain Station owners that were involved in the construction of that site back in '87, they determined that there was only a couple kilowatts heading east, and the only thing that's east is Interstate 90, Bambi, and Boo Boo. And Bambi and Boo Boo don't have radios. So that was okay. There was a lot of, one engineer who is no longer with us was disgruntled over that and felt that he wanted to have better coverage up that freeway corridor. Not a lot of people out there, but he wanted better coverage, and evidently he was able to convince American Tower that an omnidirectional antenna was indeed a requirement. And they moved from the Tiger 1 site to the Tiger 2 site to do that. The privilege that they got was a little bit better coverage up Interstate 90, and they got to see the power meter run a whole lot faster. It is interesting that with those people passing on, the question was asked by Jim Leifer and others at American Tower, do you really need that omnidirectional antenna at that location? And the end result speaks for itself.
Okay, so what he's saying here is, did the revised tower specs affect the choice? Was time a big factor?
Timing is going to, I don't think anybody wanted to rebuild that antenna. Again, because as you can see, it was a plumber's nightmare, extraordinarily time intensive to create it. And ERI in the meantime had come up with their Axiom antenna, which was a broadband solution in a rototiller format. And so there was a lot of reasons that essentially drove it in the direction. I will say one thing that's interesting is the power gain is a little better. So each of the broadcasters could back off their TPOs. It displaced some ERI equipment, some interesting equipment. If you remember several years ago, ERI came out with a solution for an in-band passive combiner system for HD radio. And 2 of the stations up there deployed that. And it was just an immense amount of hardware, big cavities, and took up a lot of floor space. And I think it was called a 466. I may be wrong on that number. But with the increased array gain, reduction in TPO, they were able to run combined mode with their existing transmitters and didn't need all that ERI hardware. So not only did this change result in a new antenna for ERI, but a whole bunch of surplus cavities that they don't need anymore for their HD combining scheme.
So the question then comes from Dave. You say arcing was the cause. Arcing from what piece to what?
According to the Tom Silliman report, and I have it here, at one point of the balun started arcing across the broken bolt, caused the metal of the bolt to melt on both sides of the gap where the bolt broke. The feed point in the monopole has a low impedance, thus causing the arc to begin. And I read that and read it, and I'll read that again. And Ira, listen close to this one. The feed point of the monopole has a low impedance, thus causing the arc to begin.
That doesn't make any sense because the low impedance would have a low voltage and therefore would less apt to arc.
Thomas, a double E, he understands Ohm's law, but you go grab this report, the cause of the Tiger Mountain Tower fire, and you can see it there. And you can go get that online. It's readily available. And as I said, I agreed with 90% of what he wrote.
I mean, if you had loose hardware and you're at a high current point, it is possible for the hardware
absolutely
to overheat. And maybe he was thinking the opposite. And as you saw from the image that I showed you earlier, it's pretty tiny stuff inside that insulated hub.
Yeah, that thing is about that big around.
Yep, or smaller.
Yep. Got any questions, Barry?
Michael wants to know, he says, interesting that the original 2-around Tiger antenna is characterized by some of the tenants as a DA and others as an Omni.
No, it should not be. There's one station on that tower that is an Omni, filed as an Omni. It's a side-mounted 4-bay rototiller on the tower. It is a DA, yes, but it's not claimed to be a DA. The existing panel array clearly is a directional antenna. It has an array gain of about 4.5, and these stations that are in that are characterized as a directional. If they're not, well, somebody screwed up.